Hello, everyone. My name is Laurel, and I'm a postdoc at Stanford working with Chris Ray, and this is joint work with Karan Goel. I'm going to talk today about a recent data-centric AI paradigm shift and the rise of foundation models, and where I think some of the key opportunities are for the data management community in supporting these new trends. To give a brief recap, the last few years have seen a lot of talk around data-centric AI and the rise of foundation models. NeurIPS had a recent workshop about this, and Stanford even has an interdisciplinary group to study these new models. This begs the question of what is this paradigm shift? What are these foundation models? And how is this changing the way in which engineers interact with both the model and the data? To understand this trend, we need to go back a few years when deep learning was taking off. Advancements in hardware and algorithms were opening up the ability to quickly iterate and build deep learning models. This resulted in ML pipelines where the point of iteration to improve performance was the model code itself. The data was fixed, and the engineers would customize and build one-off models and pipelines to solve downstream tasks. The problem with this workflow was the brittleness with this customization. Engineers would encode heuristics into how to featureize the data and how to label the data that would make these pipelines highly customized to a specific dataset and modality. It made them very difficult to maintain and extend. So starting in and around 2018, we see a rise in a new paradigm for ML pipelines, where large self-supervised models with commoditized architectures, such as the now standard transformer, were being trained over massive corpora of unlabeled data and adapted to numerous downstream tasks. Now, these large self-supervised models are what have now been dubbed foundation models because they're being adapted to many downstream tasks and are serving as a foundation layer. Now here, critically, the point of iteration is the data, not the model code itself, because these are standard architectures now. The way that you improve performance is through the data. Now, why is this shift to a foundation model lifecycle so important? One of the main benefits is the dramatic reduction in engineer effort to build and maintain models. You can have a single engineer maintain numerous different downstream tasks, all through this maintenance of the data. Further, these models often have a quality lift compared to their hand-tuned predecessors. So where does the data management community come in? Well, not an inclusive list. I see there's three main points where we can have an impact, and they all relate back to core data management problems. The first is data integration. These foundation models are increasingly being trained on more complex and heterogeneous data sets across different sources. How can we support integrating data sets over images, structured relational data, video, text, code? And we need to be able to integrate these things at massive scales. Further, we have to be able to maintain provenance over these integrated data sets, especially as companies are training over both public and private data. Privacy becomes a key concern as well. So the second is model monitoring and data exploration. As these models are trained without manual labels, engineers have a less of an understanding as to the data quality and predicted model performance. We need systems for large-scale exploration of this, again, very multimodal data, and tools for fast slice finding over structured and unstructured data like text and images that support diverse tasks beyond just classification. The last is model monitoring and maintenance. These models are not static. The underlying data, especially any structured data, is changing very quickly. This, at its core, is an incremental update problem. We need abstractions and systems to understand how to update models while maintaining certain guarantees over performance. Further, engineers are going to need tools to patch these models that all go back to the data. Things like data programming and data augmentation are to become key resources in the future for engineers to correct model performance in the face of changing data. So in the end, this rise of data is not a new trend. We've seen this in the past. However, deep learning is a commodity with larger, multimodal, and more complex data sets and larger models as well. There's a real opportunity here for the data management community to have an outsized impact on this data-centric AI foundation model trend. So thank you for listening to this very short talk, and please ask any questions.